matrix equations. At the end of lessons, students should be able to identify the different types of matrices: row, column, zero, diagonal, upper triangular, lower triangular, and identity matrices. Perform operation on matrices: addition, subtraction, scalar multiplication, and multiplication of two matrices and up to 3 by 3 matrix. Find the transpose of a matrix. Include properties. Definition of matrix. A matrix is a rectangular array of numbers enclosed between brackets. The general form of a matrix with m rows and n columns is the order or dimension of a matrix of m rows and n columns is m by n. The individual numbers that make up a matrix are called its entries or elements, Aij, and they are specified by the row and column positions. The matrix for which the entry is in i's row and j's column is denoted by Aij. Order of matrix. Example 1. Let matrix A equal 5, 6, 1 over 2, negative 2, 3, negative 7. What is the order of matrix A? So there are 2 rows and 3 columns. So the order of matrix A is 2 by 3. If A equal Aij, identify A21 and A13. A21 refer to row number 2 and column number 1. So A21 is negative 2. And A13 refer to row number 1 and column number 3. So A13 is 1 over 2. Type of matrices. The first one, row matrix, is 1 by n matrix. That means 1 row. So if matrix A is 1, 2, 3, 4, 5, then we call matrix A as row matrix. The second example is B. Number 2, column matrix is a m by 1 matrix. That means 1 column. A equals 0, negative 4. B, 2, 3, 5, 7. Example 4. Square matrix is a n by n matrix which has the same number of rows as column. Matrix A, 2 by 2, and B, 3 by 3. Zero matrix is a m by n matrix which every entry is 0 and denoted by 0. Diagonal matrix. The diagonal entries of A are A11, A22, A33, and AMM. A square matrix which non-diagonal entries are all 0 is called a diagonal matrix. Let matrix A is 2 by 2 matrix. So the diagonal entries are 2, 3. Matrix B, the diagonal entries 1, 2, 3. And matrix C, A, 0, B. Identity matrix is a diagonal matrix in which all its diagonal entries are 1 and denoted by I. Example 7. 1, 1. B. 1, 1, 1. Lower triangular matrix is a square matrix and Aij equals 0 for I less than j. Example 8. Lower triangular matrix. Upper triangular matrix. Upper triangular matrix is a square matrix and Aij equals 0 for I greater than j. Operation on matrices. Addition and subtraction of matrices. For m by n matrices A equal Aij and B equal Bij, A plus B equals C, matrix Cij, where Cij equal Aij plus Bij. A minus B equal D equal Dij, where Dij is Aij minus Bij. Note, the addition or subtraction of two matrices which different orders is not defined. We say the two matrices are incompatible. Example 10. Simplify the given quantity for A, B, and C. Find A plus B, A minus B, A plus C. A plus B equal matrix A plus matrix B. So we get here 5, 5, negative 2, 10. A minus B, matrix A minus matrix B. So we get the answer negative 3, negative 1, 8, negative 2. So we cannot add matrix A and matrix C because they are different in order, or we call undefined. Scalar multiplication. If C is a scalar and A equal Aij, then Ca equal Bij, where Bij equals Caij. Example 11. Given A equal 2, negative 4, 8, 5, negative 6, 7, find negative 1 over 2A. So negative 1 over 2A equal 2 times negative 1 over 2, we got negative 1. Negative 4 times negative 1 over 2, we get 2, and so on. Two product of two matrices A and B is defined only when the number of columns in A is equal to the number of rows in B. If the order of A is m by n and the order of B is n by p, then AB has order m by p. A row and a column must have the same numbers of entries in order to be multiplied. multiplication of matrices. Let R equal row matrix and C equal column matrix. So RC equal A1 B1 plus A2 B2 plus A3 B3 until plus AN BN. Example 12. Let matrix A equal 1 2 3 negative 2 0 5 and matrix B 2 1 negative 3 4 2 1. AB equal matrix A times matrix B. So here AB equal 2 12 and here example 13. Find multiplication of two matrices. So we get the answer here. Transpose of a matrix. The transpose of a matrix A written as A transpose is the matrix obtained by interchanging the rows and columns of A. That is, the ith column of A transpose, is the ith row of A for all i's. AMN equal AIJ. A transpose N by M equal AJI. Let matrix A equal A11, A12, A13, A21, A22, A23, A31, A32, A33. So A transpose, the row number 1s become column number 1. Row number 2 become column number 2. And row number 3 become column number 3. Example 14. Let B equal column matrix. So B transpose become row matrix. And matrix D, 3 times 3 matrix. So D transpose, the first row become the first column. The second row become second column. Third row become third column. Example 15. If matrix A equal 1, 2, 3, 4 and matrix B 3, 4, 2, 1, matrix C 1, 4, 3, 2. Show that A plus B transpose equal A transpose plus B transpose. And BC transpose equal C transpose B transpose. A plus B transpose, matrix A plus matrix B, and then transpose. So matrix A plus matrix B, we get 4, 6, 5, 5. And then transpose, we get 4, 5, 6, 5. A transpose plus B transpose equal matrix A transpose plus matrix B transpose. So we get 4, 5, 6, 5. So the answer is equal. Therefore, A plus B transpose equal A transpose plus B transpose. BC transpose. So matrix B times matrix C and then transpose. So we get the answer 15, 5, 20, 10. And C transpose B transpose. So matrix C transpose matrix B transpose So we get the answer is equal. Therefore, BC transpose equal C transpose B transpose.